Welcome. This is Chemistry 1 with Mr. Nick Lawrence again at East Central High School. Today's video 1-3 is a brief introduction over the periodic table. So in today's lesson, you're going to be able to understand the purpose of the periodic table and how it is organized by groups and families. Then you'll also be able to start to evaluate the periodic table to find a variety of chemical properties, or we might say chemical trends. The previous video dealt with chemical properties and physical properties. Today, we're going to look at the periodic table and understand a little bit more about chemical properties and what that means for certain elements. A few key vocabulary terms are shown below. These words will be used again throughout the video, so if any time you need to pause and look something up because you did not understand it in context, please do so. And as we get started, in class you should have already gotten a periodic table that looks exactly like this one. This is our periodic table of elements. Today's lesson, I will use some other versions of this, but in class, this will be the one you should rely on, and this should be the one you should get to know real well, and this is the one that you should put underneath your pillow when you sleep at night. So as we get started, I have a joke for you. If you're American when you walk into the restroom, and American when you come out of the restroom, what are you while you're in the restroom? That's correct. European. And what if you're in a hurry? Then you're a Russian. Well, the Russians in 1869 had a professor named Dmitry Mendeleev. And again, in 1869, he was a college professor, and he was trying to help his students understand elements. So he began to organize the elements in certain rows and patterns due to their chemical properties and due to the way they behaved. 1869 was an important year because that was also the year the great University of Purdue was founded. And for those of you who are Cincinnati born and bred, you might know too that 1869 was the first year the Reds the Reds became the first professional baseball team, meaning they had paid players. And so as we look at the periodic table and we see what Mendeleev started, even though this table does not look exactly like Mendeleev's, his work began to what we now have as our current modern-day periodic table. And so you will see the periodic table organizes all the different elements by their chemical properties. You're going to be seeing this a lot. We're going to be using this a lot. And so it's good to get very familiar with the periodic table as it is the backbone of our class. So the first thing to understand here is that when we look at the periodic table, we see these little things called chemical symbols. Under the 1, you see the H. That H is a chemical symbol. It's a nickname for the element hydrogen. Over here we have He. That's called helium. He is a nickname for helium or the chemical symbol. C is a chemical symbol for carbon. O is a chemical symbol for oxygen. And as you look throughout here, you might see a few weird-looking symbols that you would think would be represented by something else. Let's look at copper, for example. Copper's chemical symbol is Cu. Why not Co? Well, first of all, Co is cobalt, but also these elements have been around a lot longer than you have, and a lot longer than the English language. So many of these chemical symbols, if they're weird, it's because they come from the Latin or the Greek term. Look at iron. Iron is Fe, ferrium. If you know what a farrier is, it's a person who worked with iron, or even a person who worked with horses and put on horse iron. Lead is Pb, but you think about the word plumber, and you can begin to see where the roots came for that symbol. Silver, Ag, Argentinum, comes from the country Argentina. It was named after that. And supposedly, Argentina means land of the silver. So as we look at here, we see chemical names that you might be able to see on your periodic table. But on here, we also see chemical symbols, and sometimes those chemical symbols do not reflect the name that easily. We will learn and memorize about 25 of these chemical names, but that's not until next year. This is just a brief introduction. So how is a periodic table organized? Well, first of all, we have what's called periods. Horizontal. Horizontal means left to right. Vertical means up and down. If you can't remember the difference between horizontal and vertical, much like sometimes people have hard with their left and their right, think about vertical. If If you're a basketball player or if you're an athlete, you always want to measure your vertical, how high you can jump. If you think about horizontal, you can think about the horizon. When you look out over the ocean, the horizon goes from the left to the right. So horizontal, or periods, go left to right, and the groups, or we could also call them families, go up and down. Each of the periods and groups have different characteristics that we can suggest and we can predict, and now we've even proven about those different kind of chemicals and their similar chemical properties. One note here is we have what's called the F block, or the lanthanides and actinides, and these guys are just an extension of period 6 and period 7. Notice this is number 57 on the periodic table. This is number 58. See, the color is the same, and so this period actually goes right here with 6, and period 7 is actually a continuation of 89, 90, 91. So when we look at the periodic table, we know that there's periods and families, but the other major way the periodic table is broken down is by metals, nonmetals, and what we're going to call metalloids, which would be on the stair step. So first of all, metals are all these elements to the left of what we call the stair step. You see this like light green baby puke color, number 5, 14, 32, 33, 51, 52, 85. We call these the staircase. Everything to the left of that is classified as a metal. Everything to the right of that is classified as a nonmetal. Now, why do we call these metals? Well, because of their chemical properties. They are a good conductor of electricity and heat, and they're malleable and ductile. And these properties, these chemical properties, actually have to do with the way the electrons are arranged that we're going to learn about here in the next unit. But for right now, just understand these are called metals, and although you think of a metal as something maybe hard or shiny, technically a metal is something because it's a good conductor of electricity and heat, and because it's malleable, ductile. And these are just a few examples. Malleable means that I can hammer it out into a flat sheet. Think of your aluminum foil. Aluminum foil, you have a golf club that might be made of aluminum, but you hammer it into a sheet. Now you have it as aluminum foil. That means it was malleable. Ductile means you can turn it into a wire. You could have a ball of copper, but if I warm it up and kind of stretch it out, I can turn it into a wire that we'd use in our house to run electricity. Now we have our nonmetals. Again, nonmetals are everything to the right of the staircase, and these are classified as elements that are poor conductor. It means they don't let electricity and heat flow through them very well. And these nonmetals, when they are in a solid state, are brittle and breakable. If I have a piece of metal wire, I can bend it and it will bend and I can turn it into a ring per se. Well, if I had something like sulfur in a solid state, or bromine or iodine, any of these guys in a solid state, they're going to crumble. They're going to be like peanut brittle, brittle, that when you go to bend it, it's going to snap and break. Again, nonmetals are to the right of the stairs, metals are to the left, and so you might ask, well, what do we call the things on the staircase? Those have this very unique fancy name called metalloids. They're kind of like a metal, but not really. These elements are on the staircase, and they have similar characteristics of both the metals and the nonmetals. That's why, again, we start to arrange a periodic table this way, because we see sometimes they behave this way, sometimes they have behavior like this, and that's why they're called metalloids. We would call these semiconductors, means they can conduct electricity, but they're not as good as the actual conductors. And again, we'll go through more of those as we go through the class. So again, periodic table, gonna be your best friend. It was created in 1869 by a Russian named Dmitry Mendeleev, the same year Purdue University was started, and the same year the Reds became the first professional baseball team. But when we look at the periodic table, all it is an easy way to recognize and understand or to predict the chemical properties of elements. And we see that one of the major ways it was organized was to put the metals on the left, the nonmetals on the right, and the metalloids in the middle. So again, I hope this video is going to help you understand the purpose of the periodic table and help you understand some of the ways it's organized by periods and rows, by metals, nonmetals, and metalloids. And I also hope that this starts to give you an understanding to see why certain elements have certain chemical properties. Why does copper conduct electricity? And why does sulfur not? Have a great day.